In this geotechnical engineering lab at the University of Vermont, students learn the ins and outs of soil mechanics.
We learn about recognizing different types of soils and their engineering properties, such as how dense they can be, how light or heavy they are, how quickly water can pass through it, and how quickly they can settle, and how much. How strong are they, so we can make slopes out of them and make excavations in them.
This sort of testing is important for things like planning construction projects and water management systems. The students in this class first learned how to evaluate soil properties.
We are learning how to perform different types of soil tests that we would do out in the field, and that includes permeability tests, sieve analysis, compaction.
It's been awesome getting to learn all the tests that you need to do as an engineer. Like, we're doing it in a lab, but I can see us having to do it in the real field. Like, if you're on a project, like looking at the soil and being like, oh, is that permeable? Does that need compaction?
While these students will come away with a thorough understanding of soil mechanics, the sand-like material they're working with on this day did not come from nature. It came from the Chittenden Solid Waste District's Material Recovery Facility, or MRF. This sand is pulverized glass.
We're getting a baseline through the students here with our basic tests, and then they're going a little farther and seeing if they can do a contamination analysis for us. And they're looking at permeability, things that are important for construction materials.
Josh Tyler oversees the management of materials at the MRF. Right now, the pulverized glass, or PGA, is used in road construction projects. Tyler is hoping to find new ways and new markets to use the material.
We're looking to expand our markets, so the potential uses for this sand, it's PGA. And so one of the things we need to do is run a lot of materials testing and engineering specific tests.
A graduate of UVM's engineering department himself, Tyler knew just where to look for help with that testing.
Josh happened to call me a couple of weeks before the semester started, and he said, we are producing crushed recycled glass, and they were trying to find if there are more uses for it. And we were talking about some of the research that could be done, and then it clicked to me, and I said, I'm teaching the class on soil properties, and this material is very soil-like. Would you be open to using this in our class?
And with that, the partnership was born. To get a better sense of the materials they would be working with, the students took a tour of the MRF.
Was that your first time at a facility like that?
That was my first time at a facility like that. It was a very eye-opening experience as far as what really happens to our recycling. I mean, you kind of have a picture of it in your mind, but once you go there, it's not the same thing that you're imagining.
So, first material we're going to talk about in the last material is glass.
It was really great to just see what from start to finish, really what the process is like. So when you recycle something, where does it go? How is it measured? Then how is it sorted? What are the machine components of that? What are the people components involved with that? And then what the material actually looks like when it comes out of the facility, which is something I never knew before.
For Tyler, bringing the class to the MRF was a key component, not only to help the students understand the waste stream, but also to open their eyes to potential careers.
There's a lot of opportunities in the recycling world for engineers to really try and find solutions on where recycling goes or how to process it better.
The lessons have hit home for these future engineers.
A lot of things in engineering are very wasteful, and so we create all these carbon emissions and all this stuff, like with construction and everything. But in reality, we can be using a material that we have already used. And it's really opened my world to being able to see that and see how it could be used in potential projects and everything in the place of other material that would be typically used.
But this class is designed to have a larger impact than merely opening students' eyes to new ideas. It's designated as a service learning course, meaning that the students work with a community partner on a real-world problem.
Let's see once water starts flowing through the material if that creates an issue. Okay?
For DeWalker, that collaboration is an important part of educating his students.
I'm a big fan of service learning classes because I think it gives the class a purpose, what they are learning. They get to work with someone who is from the community, and as engineers, most civil and environmental engineers work in public sector, and it's a service-oriented profession. And it is nice to get exposure to that early on in the classroom setting as well.
As for the students, they appreciate working on something that will be useful beyond their class.
I feel really good about that aspect of the service learning project just because it gives us a goal in the end rather than just an arbitrary goal of ultimately getting that grade. You actually see where that work is being input and used for a specific purpose.
It definitely makes the class more meaningful. It's less of like you show up to lab and you learn a technique where you're not really sure when in your life you'll ever use it, especially since we all come from pretty different backgrounds and are expecting to do different things with our careers.
Teaching students new ways to think about old problems and getting them ready for the real world by giving them real-world experience. At the University of Vermont, I'm Rebecca Gollin with Across the Fence.